recording is going to take you through chapter 2, which is called one-dimensional kinematics. When I will say one-dimensional, means I am talking about either along x-axis only, then the motion is going to occur either along the x-axis only or along y-axis only, not with the two together. This is like when they are two, then when the x and y together, this is, we call it two-dimensional. Okay, then here I will say this is what we are going to study. Now the term which is kinematics, we refer to it by studying of the motion or describe the motion. Okay, then I will say, how objects move. Then when I will say how objects move, means I will maybe describe their speed, their velocity, their position, their displacement. There are a bunch of variable, I will say physical quantity that we are going to study today. Now, the first one, it is position. And all my descriptions today, they will be applied to X, but of course we can expand this also to Y. Then I should have kind of an axis here, okay, and this is the X-axis. I need to show where is my positive, and usually we take it to the right, and this is my origin. Usually my origin doesn't mean like the zero, I will say, but it will be where I have started my motion. But I should actually here mark that point because it is very important. Now let's assume here I have my car here. Okay, and this was at t equals 0. Then I will say xi, it is, and it has a vector notation here because it has a direction. And I will say it is initial position. And that initial position, it is measured in meters. And here I can say it is 3 meters. When I will have that without anything, this means that this is positive and this is to the right. Because I told you this is a vector quantity. Vector quantity means it has a magnitude, which is the number plus a unit plus a direction. Now let's assume at a later time my car was here. Now this is 4, 5, 6, 7, 8, 9, 10. Then this was xi 3, and that one was x final 10. Okay, then here I will say xf, it is my final position, and this is also measured in meters, and it's going to say this is 10 meters. Now, I can also now define something. I will call it delta x. That is what is called displacement. And displacement, we define it in two ways. Change in position. Okay, and always change, it is final minus initial, always. Okay, then that number can become to be either positive or negative. Positive means along the positive x-axis, then towards, okay, then it's all along, like, okay, then it is towards, and that is toward the negative x-axis. Now, I can also here then calculate the displacement for my car, which is going to be x final minus x initial, and that is 10 minus 3, which is going to be 7 meters. And you know also here that it is positive because it was toward the positive, okay? And this is, you know, I can also maybe say, what about if I have the opposite? The opposite is when I have, this is my positive x-axis, then I have my car initially was at 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then my car was here. This is my xi, 3 meters. 10 meters. Okay, let's erase that. X initial, 10 meters. And here, x final is 3 meters. Then I can say here that the displacement is going to be the final, which is 3 minus 10, and that is going to be the negative 7. Okay, then this means that my object is moving to the left, okay, and that's true. Now, if I want to calculate what is the total displacement here, this means I will have x, the first one, which is plus, minus the second one, and that is 0. Then the displacement, it can be positive, it can be negative, it can be 0 as well. But if I'm asking you about what is the total distance here, then we can say it is 7 plus 7 because distance is a scalar and is going to be the total 14 meters. Okay? Now, this is the most important difference between displacement and distance. Then displacement is telling you one of the things like the change in the position, or like sometimes how far from origin. And I will say origin, it is when the start of the motion. It's not necessarily my 0. All right? And for distance, it's the actual, or like I will say, the meters that we have for your all motion. Okay? Now, I will say, now I need to have a definition of, or like also differentiate between two things. One of them, it is speed, and the other one is velocity. And here, when I talk about these, I need maybe to talk about something called average or instantaneous. Let's start with average. Average speed is going to be total distance by total time. And here, if you have any waiting time, like you fill gas during the trip, you stop by 7-Eleven to get some snacks, or whatever you did, like this extra time should be added. Now, if I want to calculate the average speed in that system, which we are using the SI system, then we're going to have units meters per second, meters per second, meters per second. If I wish to calculate now the average velocity, it has direction in it, and it's going to be the total displacement divide by the total time. And also, I will say we can write it in the notation. And again, the time, if we have a waiting time, it should be included. X final minus X initial divided by time. And this is, again, meters per second, meters per second, meters per second, like this. Now, one of the things that I need maybe to say here, we are in physics, we are using graphs widely. Then I want to tell you here some of the information about what is really how we are going to read these graphs and know something about the motion of the object. Now, the first thing is, I will say I have here my X and here my Y. And I will not use X and Y in here because now I'm talking about description of the motion. Then what I will use for the Y, I will use the displacement in meters. And here I'm going to use the time for seconds. Now, one thing that I want you to know here is that I can maybe describe a motion of an object like this. Okay, and maybe this is 5. Now, and I might ask you, okay, let's tell me the story of this object, how this object is moving. And I will say, I'm going to give you maybe like just 2 minutes, not 2 minutes, like 30 seconds to look at the graph and think, and then I'm gonna answer the question. All right, I think now you have enough time to think of it. And if you found that this is your description, you are right. Why it is no motion? Because I was looking at the object, it was at 5 meters, and then after maybe another second, it was, let's say I have the time here, like this is 1, this is 2, this is 3, this is 4, okay? Then I know that I'm looking at the object at every instant, and the object is still at the same distance or displacement, which is 5. But also, I might have something like this, where I'm gonna have X on the Y and T here, and I might have something like this or like this. Okay, I want you to know always when I have XT graph, I can calculate velocity from slope. And here the slope has only one value, and this is the reason why it will be for these two moving with constant velocity. But just one thing is the black is moving to the right, okay, and the purple is moving to the left. Why? Because the slope of the first one is positive, the slope of the second one is, the slope of the first one is positive, the slope of the second one is negative. Always when you are going to know something about the direction of motion, you need to know that the direction of motion has to do with the direction of velocity. Then if your velocity came to be negative, this means that the object is hitting west. If your velocity came to be positive, then your object is hitting right or east. Another graph here. We did not talk yet about acceleration, but I want to add that. Okay, xt graph is going to be something like this. And this one, we will talk about it later. It is describing constant acceleration, not constant velocity, constant acceleration motion. Now, I might have also not x versus t, I might have v versus t. And then my graphs, they're going to be looking like this. Okay, let's see here. If I have, okay, v now here, you have to check before. Okay, then if it is like this, this means constant velocity. And if it is with constant acceleration, the graph is, if the v versus time is gonna look something like this. This is constant acceleration motion. You should understand these, and if you have any problem, let me know. During office hours, you can join me. Now, I can say here, this is just one of the checkpoints. Which means I want to check your understanding. And then here I have, this is point 1, point 2, point 3, point 4, point 5, time in seconds, and this is x in meters. Okay, and let's assume here that I have my object is gonna have this type of motion. Okay, now how can I move from this graph to the, I will say, VT graph? I want to draw this in, you know, like now, but just I want to maybe say something. I need first to calculate the slope for this one because this is going to give me the velocity. The slope is 3 minus 0, the rise, divided by the run, which is the 0.25 minus 0. Then it's going to be 3 divided by, okay, it's going to be here, 3 divided by 0.25, and that is going to be 12 meters per second. And I think the graph is showing that it is symmetrical. Then I will say the other one, like, you know, the segment, the first one here, this is 1, slope 1, and here slope 2, it is negative 12 meters per second, because I need this value for the next graph, which is going to be V versus time. And here I can have another scale for velocity because my numbers are different. Okay, and I know that my object has changed its motion here. And I know that this is might be something like -5, not 7, 10. Oh, sorry, what's negative? It's positive here. Okay, 5, 10, okay, 15. Okay, then I'm gonna expect the 12 maybe to be somewhere here. Okay, and the velocity here is constant at 12, and I know that here is gonna be -5, -10, and -15. Then I'm gonna expect something maybe like this. Then this is going to be the shape of my graph. The black one is going to give you the velocity versus time. I will stop here. I want to dissect the course, the chapter into more segments. Sometimes I'm afraid that I will not have an audio, like I don't know, sometimes like the switches, they're going to move, or because I want to have it like for you also easy, and for me also easy to upload. Thank you, and see you soon.